Being awarded a National Institutes of Health project grant, or R01, is an important step in one's career as an independent scientist. The NUCATS Institute helps prepare investigators to reach this point for a career in research through a variety of resources and educational programming and support. Today's guest, Dr. Sadia Khan, was recently awarded a second R01 grant, an exciting and rare feat for an investigator at this stage in her career. She joins me today to talk about her research at Northwestern and offers advice on how to access the NUCATS Institute suite of services, tools, and programs to advance your own career. But before we get started, please subscribe and ring the bell to be notified of new videos. Welcome to the show, Dr. Khan.
Thank you for having me.
This podcast is called Science in Translation. What does the name of the show mean to you?
I think the word translation has many different meanings, and it can be applied to NUCATS in the same way. Translation can mean translational science in terms of understanding mechanisms. Translation can mean translating discoveries from the lab or from epidemiology and population health to the clinic. I think translation implies a dynamic nature of science and of NUCATS, which is what I find so perfect about the title.
You have called Northwestern University home since you were a freshman on the Evanston campus. Share your story with me from an undergrad at Northwestern to now a PI, a cardiologist, and assistant professor here at Northwestern.
I think some would say that I bleed purple, and at this point in my life, I have been at Northwestern more than half of my life, and I've had the opportunity to experience the Evanston campus as well as the downtown Chicago campus. I entered college knowing that I wanted to go to medical school and was so fortunate to be accepted into the honors program in medical education, the combined degree BS-MD program at Northwestern. And that really was the beginning of a wonderful journey. And I'm so grateful to have had that opportunity because it allowed me to connect with mentors and individuals at the Feinberg campus, even as a college student.
So you knew early on you wanted to be a physician. What about becoming a physician scientist? When did you decide to take this path?
I always knew that I was interested in doing research. And as an undergraduate, I had the opportunity to work in a biomedical engineering lab led by Guillermo Amir. And during that time, I really got exposed to some fascinating work in tissue materials and engineering. As I moved on to medical school, I became interested in cardiology and specifically heart failure. Being exposed to clinicians and physician scientists and mentors on the Feinberg campus as a student really opened my eyes to the potential opportunities of different career paths. And that was when I first started getting interested in understanding what the role of a physician scientist and the career of a physician scientist might look like. As a third-year medical student, I had the opportunity to round in the heart failure service with Mihai Georgiadi. And for those who may remember Mihai, he was a legend. He was someone who had really transformed how we approached acute decompensated heart failure and really never stopped pushing the question, why? I think for me, this was the most important aspect that instigated my love for research was this question that keeps pushing us to say, why is this happening? Why is this the case? Why is this the mechanism by which we think something may happen? As a fourth-year medical student, when I was applying to internal medicine residency, I learned about the physician scientist training program at Northwestern and clearly realized that this was the perfect path to pursue my dreams of becoming a physician scientist.
So you started working on other people's projects. When did it get to the point where you were taking on your own research projects?
That's a great question, and I think is a challenging transition point. Oftentimes, as a resident, as a fellow, you're really learning skills. And during that time, being able to collaborate and contribute to other projects allows you to build up this skill set as well as start to sample and understand what are the types of research that you want to be working on. And I think that was really important for me to be able to think about what were the types of projects that inspired me the most? What were the types of questions that really kept me most interested in being able to do this type of work? And it was during that transition from fellowship to faculty that I really started to crystallize around key concepts that I wanted to focus on as a cardiovascular epidemiologist, focused on heart failure prevention and women's cardiovascular health as my two key areas of focus now.
So let's dive into those a little bit. You've authored more than 200 publications. Share with me some of your most significant findings.
I've been really fortunate to work with an amazing team of mentors, colleagues, trainees, and we've put together a really nice group of projects that have covered several key areas. The first one that I'll talk about is surveillance epidemiology. I think we've all become really aware in the past several years with COVID how important it is to understand disease prevalence, disease burden, mortality. Well, we really wanted to do the same for cardiovascular disease outcomes and adverse pregnancy outcomes. So, two of our main papers that have really highlighted the increasing burden of cardiovascular disease mortality as well as adverse pregnancy outcomes and have connected the two ideas in some of our grant work as potentially coming from the same reasons in terms of overall heart health declining in the United States have been really impactful and important both for me as well as our research team to try to highlight what the scope of the problem is and then set about identifying ways to solve it.
For someone who's still relatively early in your career as a physician scientist, you've been able to accomplish quite a bit. And I want to talk about the role that NUCATS has played in your career. Take me back to your first exposure to NUCATS. When did you start interacting with the Institute?
During my fellowship, I became interested in gaining additional training, and I first encountered NUCATS through the Masters of Science in Clinical Investigation program. And I was fortunate to be able to participate in this program as a clinical cardiology fellow, and it really set the stage for my next interaction, which I think was really the transformational phase in my career when I was able to participate and be awarded the NUCATS Mentored Career Development Award, the KL2.
This is a 2-year program. It's a very important focus of NUCATS. Explain it to me and what you accomplished while you were in the program.
The NUCATS KL2 program is really a critical part of that transition from fellowship to faculty, when funding support can really help identify individuals who are on a trajectory to have a successful career as an independent scientist, but have not yet competed for extramural funding like a K-23. At the time when I applied for the KL2, I was starting to develop some of my own independent lines of research, but it wasn't yet solidified, and I needed that additional time and support, as well as the incredible resources that NUCATS provided by connecting me with mentors, with peer mentors, and experts in the areas that I was interested in to help me develop my research program. The KL2 program is a 2-year program for faculty to support 75% of their time in research. And the goal is to be able to not only have that time protected to pursue your research, but also to provide the mentors and networking needed to be able to develop new skills, identify resources that are needed to execute the research, as well as start to develop the preliminary data needed for the next award application, whether that's an extramural K award like a K-23 or an independent award like an R01. One of the things about the KL2 that's very unique is the partnership with what is called a ramp mentor. This is specifically a methods mentor that can help guide you in an area that you are interested in pursuing.
I'd love to hear about some of the mentors that you've had.
I was so fortunate to meet Dr. Douglas Vaughan, the chair of the Department of Medicine, and Dr. Donald Lloyd-Jones, a former director of the NUCATS program, between Don as an epidemiologist and Doug as a basic and translational scientist, that allowed me to develop my own niche as a translational epidemiologist and be able to bring the best of both of these worlds together.
So, what were you working on during the program?
During the KL2 program, I was focused on expanding my skill set in cardiovascular epidemiology, specifically in molecular epidemiology. I was interested in better understanding mechanisms of cardiovascular disease and using different, what we call omics strategies to better understand that, whether that's epigenetics, genetics, proteomics, transcriptomics, really understanding why things happen the way they do, and specifically for cardiovascular health, what are the mechanisms that can promote cardiovascular health or be associated with poor cardiovascular health? As I was developing my research program, I was gaining more and more interest in how we can better estimate risk for heart failure. In the field of cardiovascular epidemiology, we've paid a lot of attention to atherosclerotic cardiovascular disease, and much less so to heart failure. I had the opportunity to lead a multi-cohort collaboration to develop risk prediction equations for heart failure. This paper was then published in the Journal of American College of Cardiology entitled 10-Year Risk Equations for Incident Heart Failure in the General Population, and has now been cited by the 2022 ACC/AHA heart failure guidelines to really help change the paradigm of heart failure prevention by focusing on risk prediction.
How do you feel like you grew as a scientist during the KL2 career development program?
During the KL2 career development program, the exposure to mentors, to methodological experts, to peer mentors, particularly through the seminars where we were able to interact with other case scholars, really helped me grow, not just in my science, but also in my professional development, and allowed me to network with other individuals, identify extra institutional opportunities, such as speaking opportunities at national conferences and presentations like grand rounds at other institutions, and helped me start to develop my voice and my niche in the research world.
Tell me about how you got your work funded from the point of being in the KL2 program to graduating from the program, and what happened next. How did that work?
Well, first, I have to say, after many, many failures, did I get my work funded? So I think that's one of the most important lessons in terms of being a clinician investigator or an investigator. There are so many more failures than there are successes. And I think it's really important that we talk about them and normalize that ratio of failure to success. And in some ways, and I was mentioning this recently to a mentee, having a grant not funded is not a failure. Having submitted a grant is a success in and of itself. Once I completed the KL2 program, I was applying broadly, both for NIH R01 awards as well as foundation awards. I knew during this transition time that I needed to get my work funded, and I wanted to cast a broad net. So I think that's the other lesson that I think is really important as someone is getting started. It doesn't matter where the money comes from. Finding funding to be able to pursue your passions and your interests in research is most important. I was fortunate to be successfully awarded an American Heart Association Transformational Project Award, which was an independent project award with 3 years of funding that allowed me to bridge my time from the KL2 to when I was awarded my first R01 last year.
So, about the R01 Award. Now, this is one of the most significant research awards given by the NIH. Tell me, what does this mean to you as an individual scientist and to your team?
It's an incredible honor to be funded by the NIH, and particularly the R01 really affords the opportunity to be able to build my research program, to grow my team, and be able to focus on the questions that I think are most impactful. My first R01 is focused on cardiopulmonary health across the life course, and I work closely with Dr. Ravi Callahan, who's been a new mentor for me in terms of better understanding the interactions between lung health and heart health. One of the reasons that we got so interested in this project was as the COVID pandemic began, We started to think not just about the cases of severe COVID, but about the number of people, which we think maybe more than 80% of people who have now contracted COVID-19 and recovered, what that means for their lung health and what that means for their heart health. And we wanted to ask this question in data that existed before COVID to better understand the mechanisms that connect lung health and heart health.
And how about your second award? Tell me about the details of that.
The second award is in my second line of research interest in women's cardiovascular health. This award is an ancillary study to the New Mom to Be Heart Health Study, which is a cohort that was originally funded by the NICHD and enrolled about 10,000 pregnant people across the United States. And the Heart Health Study, which is a follow-up of that, enrolled about 4,000 people who are now between 2 and 7 years after that first pregnancy to evaluate their heart health following the pregnancy and examine if there were associations between adverse pregnancy outcomes like preeclampsia and gestational diabetes and later heart health. Our award will be focused on measuring carotid ultrasound measures of subclinical atherosclerosis, which means looking for evidence of atherosclerosis or plaque buildup in young, healthy people before they might have any signs or symptoms of heart disease. And we're hoping this will help us better understand if there are pathways from which someone might go from having an adverse pregnancy outcome to being at risk for heart disease so we can better intervene.
Those both sound like really exciting projects. And I want to go back to something that you were saying before that to get to this point to be awarded R01s, there was a lot of work that went into this and some failures. Tell me, how did you start prepping for these awards? And what was that process like to getting to this point where you are today?
I learned a lot along the way. And I think one of the most critical things was how important planning and timing out the application process can be in being successful. On average, I would recommend somewhere between 6 to 9 months before an application deadline beginning preparation for submission. While this might seem like an excessively long time, that amount of time allows you to plan and revise and get feedback and input. I know for a fact that the ability to share these applications with mentors, with colleagues, with peer mentors was critical in my ability in putting forward the best application I could.
Tell me about the foundation that NUCATS helped to provide during this time.
The ability at NUCATS to provide support, including for methodological support as well as feedback and mentorship, is really critical in terms of putting together a strong application. For one of my other awards, the R01, which is a clinical center for heart share, we participated in a NUCATS studio to learn about all of the resources available at NUCATS that we could put forth in our application to highlight the strengths of the institution and the ability to successfully compete as one of 6 clinical centers for this new NHLBI-funded cohort was really essential.
What other NUCATS resources have you utilized or will you continue to utilize with these grants?
The other resource that's really been critical in both grant preparation as well as execution of research has been the BCC, or the Biostatistics Collaborative Core. Being able to access biostatisticians that have specific expertise in epidemiology, causal inference, and work collaboratively in preparing an application or executing the science has been really transformative in the preparation of these proposals.
What would you say to someone listening who is interested in having a career like yours someday? How can NUCATS help them?
The amazing part about NUCATS is that while I'm one person that has utilized the services of NUCATS, there are so many more people like me that have contributed to NUCATS, that have participated in using NUCATS resources. And this really pulls together an incredible network of multidisciplinary, like-minded people that are interested in advancing science. And I think one of the most important things as you begin to develop your career is finding your research home. And that's what NUCATS has been for me. My research home that has provided me the foundation or the first floor in building my research program.
Well, Dr. Sadia Khan, thank you for coming on the podcast, talking about your experience with NUCATS.
Really honored to be the first guest. Thank you so much.
Subscribe to Science in Translation wherever you listen to your podcasts. To find out more about NUCATS, check out our website, nucats.northwestern.edu.